Well, welcome back, Dartmouth. All right, so we have a really good understanding of the structure of an atom. We understand that the atom has a nucleus. Inside the nucleus, we have our protons and our neutrons. That's where we get the mass. Around the nucleus, we have the electron clouds, which is where we can find the electrons. The number of protons is equal to the number of electrons, so all atoms are neutral. Number of neutrons does not have to be the same. They have no charge. Um, Yada, yada, yada. Okay, so now let's try to get a good understanding of the structure of the periodic table, which of course is the chart that contains all of the elements that are made up of these atoms. Okay, up until the 1860s, there was really no way to group the elements. Along comes a Russian chemist named Dmitry Mendeleev, who discovered a pattern in the elements. Um, and the way that he did this was basically really simple. He wrote the names and properties of the elements on different cards, and he arranged the cards based on those different properties until he finally found one where a pattern evolved, and that was when he arranged them in increasing atomic mass. And there is a short, sweet version of Mendeleev's periodic table. Now, you can see at the time he did not have all of the elements. They had not yet been discovered. So he used what he had. Now, he found that when the elements were arranged in order of that increasing atomic mass, that similar properties occurred in a repeating pattern. The pattern was periodic, which means repeating, or happening at regular intervals. And so he named his table the periodic table of the elements. Now, if we take a look at his periodic table, again, we didn't have all of the elements that had been discovered yet, but you can see that he left gaps. He had question marks. And so he was predicting elements that had not yet been discovered, and he was predicting where those elements would fit. And of course, he was right. Now, was his periodic table perfect? No, but it was a wonderful beginning. Now, a few elements didn't fit into the pattern of Mendeleev's periodic table, but he thought as technology got better and that we had these more accurate atomic masses, that maybe those flaws would then get fixed. However, those new atomic mass measurements showed that the masses he had already used were correct. And so in 1914, Henry Moseley, who was a British scientist, said, let's arrange them based on their atomic numbers, or their number of protons in the atom. And what he discovered is that all the elements fit the pattern in Mendeleev's periodic table when he did this. So that all elements follow the periodic law, which of course states that repeating chemical and physical properties of elements change periodically with the element's atomic number. So where Mendeleev had a great beginning and he arranged his based on increasing atomic mass, Bosley came along and did it based on atomic number. Okay, so again, Mendeleev did his based on increasing atomic mass and did a fantastic job getting it started and set up. Moseley came along and did it based on increasing atomic number, or the number of protons, and everything fell right into place. And so here we have our periodic table. And I know it looks a little funny, but there is actually a reason or a method to all that madness, and we're going to talk a little bit about that. Now, it does seem confusing at first, but it's really easy to use once you learn how. All of the elements are classified as to whether they are a nonmetal, metal, or a metalloid, and that's all based on their properties. The number of electrons and their outer energy level of an atom is one characteristic that helps determine which category that element is going to belong to. And if you remember, when we talk about electrons, we know that they are in different energy levels based on how much energy they have, and that those are what bond and interact with everything in the environment. There's also a zigzag line on the table, and that can help us recognize which elements are metals, nonmetals, and metalloids. And so here we have a periodic table. You will notice everything on the left-hand side, except for hydrogen, is a metal. Everything on the right-hand side is a nonmetal. And here we have our zigzag line separating the metals and the nonmetals, and that's where we have our metalloids. Okay, so as we saw from the picture before, look at all of these things, all these green, those are all metals. Most elements are metals, and the atoms of the metals have very few electrons in their outer energy level. Some of the properties that they have in common, they are shiny, they are malleable, which means they're bendable. They are ductile, which means they can be pulled into wires. They are good conductors of heat and electricity, and they're good conductors of heat and electricity. Some of the metals, brass, aluminum, cast iron, copper, steel, bronze, all of those are made up of metals from our periodic table, like iron, cobalt, nickel, copper, aluminum, gallium. Now the nonmetals. Most of the nonmetals have a complete set of electrons in their outer energy level. And more than half of the nonmetals are gases at room temperature. So some of the properties that those nonmetals share, they are not malleable or ductile. They are not shiny, and they are poor conductors of heat and electricity. So notice the exact opposite of the metals. And those nonmetals, iodine, chlorine, astatine, bromine, and so on. Now those metalloids, which are also called the semiconductors, those were the elements that were along that zigzag line that separate the metals from the nonmetals, have about half a complete set of electrons in their outer energy level. They are shiny and brittle, they are hard and brittle, and they are usually good conductors of heat and electricity. So you can see we've got a little bit of both metal and nonmetal going on here. So boron, silicon, arsenic, antimony. Now, on the periodic table, each element is identified by a chemical symbol. And in each square on the periodic table, we're going to have the element's name, their symbol, mass, and atomic number. Now, when we're talking about their chemical symbol, if it's one letter, it's just one letter capitalized. If it's two letters, the first one is capitalized and the second one is lowercase. So here you can see everything that's inside the box on the periodic table. We have our atomic number, which is how it's arranged. We have our symbol, we have the name, and then we have the mass. Now, there are also, as you can see from the periodic table, rows and columns. Each horizontal row is called a period, and there are 7 horizontal rows. Each vertical column is called a group or a family, and there are 18 of them. And you are going to be getting your own periodic table, and we are going to put a lot of information onto it, and you can color code it so that you'll be able to use it and understand how to use it. Talk to you later.